Hello guys, welcome. I'm Kumar K, your favorite DSA teacher when it comes to hard and seen DSA problems of top tech companies' online assessments where students face issues and interesting competitive coding problems. Today is a very great day because we are going to solve a 2900 plus rated Codechef problem, which if you solve in the contest, you can reach 7 stars on Codechef. Out of 30,000 to 40,000 people who gave the contest, only 5 to 10 people were able to solve this question. So let's get straight to the question. So hello guys, we start with the name of God Ram Ram. As we proceed to solve this problem, it's very important that we know the basic concept of palindrome. Uh, I give you a string S A B A. It is a palindrome. Okay, palindrome. Let's say P is palindrome. Why is this palindrome? Because the first character is matching the last character, second character matching the second last character, and the middle can be anything, does not matter. Similarly, if I give you one more string, let's say B, and yeah. So why is this palindrome? First character matching this character, and the second character matching the second last character. If it's even size, then the middle character will not even be there. So guys, what is a palindromic string? Palindromic string. This is a palindromic string. Palindromic string means that you can rearrange it to become a palindrome. Can you rearrange it to become a palindrome, guys? Think about it. Yes, you can rearrange it to become a palindrome. You can very easily rearrange it to become a palindrome. How can you rearrange it? Well, you can put the B in the middle and this will become palindrome. So guys, if I give you any string, how will you know if it is palindromic or not? How will you know if you can rearrange that string to become palindrome or not? So let's say A, B, B, C, C, D, D. Can you convert this string to palindrome? If you can convert it to palindrome, then you can say that yes, this is a palindromic string. Can you convert it to palindrome? Yes. The first A I will write here, the last A, the second A I will write here. The B here and then this B here, this C here, D, D. It has become a palindrome. See, this is matching this, this is matching this, this is matching this, this is matching this. So guys, it gives us the hint that if each character is coming even number of times, if each character, let's here A is coming 2 number of times, B is coming 2 number of times, C is coming 2 number of times, D is coming 2 number of times. If each character is coming even number of times, then the string is palindromic. You can convert it to a palindrome. So this thing is clear. Now, there is one special case. Here, each character is not coming even time. Still, it can become a palindrome. Why? Because at most one character is allowed to come for odd times. See, this is even. This is odd. One character is having odd frequency, that's okay. Why? Because the even will come here like this A, then B, then CC, then DD, and whatever is the odd frequency, you will put that character in the middle and the job done. But guys, if two characters have odd frequency, then you can never rearrange them to palindrome. For example, so if two characters are having odd frequency, then it's never possible. Hopefully that thing is quite clear in your mind and in your brain. So why? This A I will put here, this A I will put in the end. So these two A's have been used. This B I will put a second and this is second last. So B and B. But this A and this B is a pending. So if you put them here, this is matching this is matching this, but these both will not match. So guys, the hypothesis says that, let me explain that to you people, that this is a prerequisite. Okay, the prerequisite is the basic, very important prerequisite for our particular coding question is that a string can be converted to palindrome if and only if either one character has odd frequency or zero character has odd frequency. Okay, so guys, if you have done our 850 hour course now, there is a, if you are doing our 850 hour DSO CP course, there is a specific section I have made where we discuss the hard unseen DSA problems of OA and CP, which are based on string plus lexicographically minimum plus palindromic concepts. Mixing these concepts, many high quality string questions can be possible. So if you have done those things, this question is a piece of cake. Even though this is 2900 plus rated 7-star problem, all it involves is palindromic concepts and lexicographic minimization of the subset or the string you're choosing. So this palindromic concept is clear to you. Now the next prerequisite is you should know what is the lexicographically minimum. So guys, if I give you two strings, how will you know which string is lexicographically minimum? Which string is minimum in both of them? First you check the first character. You check the first character. This is A, this is Z. This is smaller, right? This is smaller. Because this is smaller, you can say that AZZ is the lexicographically minimum string. But what if both the only the first character matters? But what if both the strings had the same first character? Then what you would do? They both are same. So now you will check the second character. In second character, if you see that you know Z and B is there, so B is smaller. So ABZ is lexicographically minimum string out of both of them. So this concept is also clear. Now we rush towards the question. So Ram Ram. So guys, in the actual question, they are saying us that you are given a string, convert it to non-palindromic string. Convert it to non-palindromic string by removing some characters. So basically, you have to convert it to non-palindromic strings by removing some characters. Non-palindromic string is which string? A string which has, let's say, A, B, C. Let's say this is our hash map and we know the frequency of each character, okay? So, if there are two characters, if there are two or more characters which have odd frequency, then you can say that, then you can easily say that this string is non-palindromic. So let's say S is this. Now, if I make a hash map of it, storing the frequency A coming 4 times, B coming 4 times, C coming 2 times. So now guys, the thing is that, the thing is that all are coming for even number of times, but we want non-palindromic. We want two characters to have odd frequency. So let's make this C have odd frequency and let's make this B have odd frequency. Then what will happen? You can say that A is coming 4 times, you will remove one B and B will come 3 times, C will also come 1 time. Now guys, this is also coming odd number of times. This is also coming odd number of times. Both of them are coming for odd number of times. So now you can say you successfully convert it to non-palindromic. So you will remove one B from here and one C from here. Now the leftover string is non-palindromic. There are two characters having odd frequency which is non-palindromic, can never be converted to a palindrome because two characters are having odd frequency. So this question is very easy, like anyone can solve it, right? What will be the normal solution if we consider only this question? The normal solution will be, first you check the given string. If the given string is already a non-palindrome, then 0 is the answer. You don't need to remove anything. Okay. But let's say if it is having all even characters, let's say in this string all guys are coming for even number of times, all guys are coming for even number of times, okay, then you can simply select any two characters. You can select any two characters. You can select any two characters and reduce their frequency by 1. So I select A, I reduce its frequency by 1, it becomes odd. I select B, It was coming even number of times. Now I reduce its frequency by one, it becomes odd. Job done. So just two characters enough to solve the question. Yes, it can happen. It can happen that one character is odd and all other are even. That can also happen, right? So in that case, only one character is enough to solve the question. Let's say A is coming odd time, B is coming even time, and then all from B to Z are coming even times only. We want two people to be odd, so one person is already odd. So second person you will change it and make it odd by reducing by one. So only one character change is enough to make it non-palindromic. What if already two or more than two characters are having odd frequency? Then it's already non-palindromic. So this problem is easy to solve. What makes this problem tougher is that they are saying that whatever characters you're removing na, they should be lexicographically minimum. If there was, see, if they said that remove any characters na, if they said that remove any characters to make S non-palindromic, then this is super easy question. You can easily select one or two characters from the characters having even frequency, make them odd, job is done. But now they are saying you cannot remove any character. Whatever characters you are removing now, you will remove a subset of characters. What you will remove? A subset of characters. But that subset should be lexicographically minimum. That subset should be lexicographically minimum. So now this creates a little bit of problems. But don't worry, you are Kumar ke sir is with you. We can do it. Okay, we can do it. Now, so let's discuss some cases. Let's say the case of triple A, triple B, double C, double D. Triple A, triple B, double C, double D. In this case, you have to convert it to non-palindromic. Let's say NP is non-palindromic. This is already non-palindromic because this is also coming odd times. This is also coming odd times. So you need to do nothing. Answer is zero. No operation you need to do. Now let's take another case. Another case is 4 times A. Okay. 2 times B and 2 times C. You can see A is coming 4 times, B is coming 2 times, C is coming 2 times. You have to make two of them odd. So what is the easiest way? Make this guy odd. Make this guy odd. So reduce B by 1, reduce C by 1. So 1 B I will remove, 1 C I will remove. So if I remove B and C, if I remove B and C, the leftover string is triple 4 times A, B and C, which is non-palindromic because two characters have odd frequency there. So BC is the answer. BC is the answer. This is our sane mind telling us that the answer is BC because if you remove BC, basically you will select the subset BC. Because if you remove this subset, the leftover string will be non-palindrome. But the correct answer is the correct answer. Yeah, it was what? A triple, yeah, 4 times a double B. Okay. The correct answer is, we are saying that BC is the answer. But the correct answer is 4 times ABC. This is the correct answer. And this is wrong answer. Why BC is wrong? BC is a correct valid subset. No problem. देखो ध्यान से बात को समझो. If you try to remove BC, then the leftover string is non-palindromic. But if you remove triple A 4 times A B C, then also the leftover string is non-palindromic. Let's remove 4 times A single B and single C. Then the leftover string will be what? BC, which is also non-palindromic. So which one will you output? Will you output C? BC is also valid and 4 times A BC is also valid. You have to output the lexicographically minimum of all the options. Both are valid in this case. Which is lexicographically minimum? Don't go on the size. First we check the first character, right? So B here, A here. The first character is smaller in this case. So 4 times A, BC is the lexicographically minimum, even though its size is larger than BC. Ha ha ha. Now I hopefully you understood why the question is difficult. because you cannot randomly remove any characters. You have to remove such a subset of characters such that they are lexicographically minimum, guys. So these many things I have solved for you. Great job. Lovely, lovely. Now, what do we have to do? Now, if we scroll below, guys, one edge case we can easily handle if all the characters are same. Now, then no matter what you do, if all the characters are same, now then no matter what you do, you remove anything from it, it will always stay a palindrome only. So you cannot do anything. So minus one answer. Okay. So make sure you handle this edge case properly. Okay. So now how do we begin to solve this problem? So guys, if I start the thinking process in front of you now, we want to select a subset of characters such that when they are removed, the leftover string is non-palindromic. Leftover string is non-palindromic. Okay. Leftover string has at least two characters which have odd frequency. We will store the frequency of each character in hash map. Frequency of B should tell us how many times B is coming in that hash map. We want the subset of characters should be lexicographically minimum. It means the first char of the subset should be as small as possible. So let us try to make A as the first character of our selected lexicographic subset. So guys, let's say I give you this string. Okay, my lovely student, I give you this string. Okay. You have to make it non-palindromic. You know that A is also coming even number of time, B also coming even number of time. Both of them need to come odd number of time for it to become palindromic, non-palindromic. So you have to remove some subset of characters. You have to choose some characters and remove such that they are lexicographically minimum. लेक्सिकोग्राफिकली मिनिमम का मतलब क्या होता है? What is the meaning of lexicographically minimum? It means that the first character should be as small as possible. First character should be as small as possible. So which first character is as small as possible? ये स्ट्रिंग में से कौन सा कैरेक्टर निकालना चाहिए कि अपने सबसेट में वो कैरेक्टर जब आए तो सबसे छोटा हो? Basically, I'm saying that your task is that remove one character from this string. Remove one character from this string. And that character, you put it in this subset. And this subset should be lexicographically minimum. So, if you want this subset to be lexicographically minimum, it means that this should be the smallest character of the string. So, you have to remove the smallest character of the string and you have to see if this is working out or not. Okay. So, what will I do, guys? I will try to remove A. Okay, I will try to remove A. And I put this here. Now guys, how will I know if this was a valid move? How will I know if this was a valid move? If I remove A from here, I will check the leftover string. What is the leftover string? Triple A 4 times B. So one guy is coming for odd number of times. One guy is coming for even number of times. Can this leftover string be solved in the future? Can this be solved in the future? Yes, it can be solved in the future. Why? Because in the leftover string, one guy is coming odd number time, one guy is coming even number of time. So whatever is coming even number of time, na? Whatever is coming even number of time, na? If I reduce one in it in the future, it can be solved. Because it can be solved in the future, you can say that you are allowed to select the first occurrence of A as the first character of your lexicographic minimum subset. Now someone could have told me that, sir, why are you not trying first character as B? Because A is smaller than B. And I want the first character I am removing as small as possible. Because I want lexicographically minimum subset to be removed. So guys, this trick is pretty simple, that let us try to make A as the smallest char in the whole string. Okay, smallest char in the whole string, the first char of our valid subset. Now, how will we know if choosing this is valid move? Let us say that the leftmost occurrence of a in the whole string is I. Okay, let's say this is I equal to 0. Okay, okay sir, you are removing this and putting in your subset. Now how do you know that this is a valid thing to do? Greedily, how will you know that if this is a valid thing to do? This is a valid thing to do if and only if and only if and only if, my lovely hardworking professional best students, if and only if the remaining string is can be solved in the future. Okay, so basically I will say that removing a from index I of string s is a valid move if and only if the remaining string can be if and only if the remaining string can be solved in future. Whatever you remove, you put it in your lexicographic minimum subset. So guys, here I can remove this a, because if I remove this, this is the leftover and this can be solved in the future. Why can it be solved in the future? मैं कह रहा हूं कि ये फ्यूचर में बचा हुआ पार्ट सॉल्व हो सकता है. ये क्यों सॉल्व हो सकता है? क्योंकि एक इसमें ऑड बार आ रहा है, एक इवन बार आ रहा है. तो जो भी इवन बार आ रहा है उसको तो मैं ऑड बार कर सकता हूं ना फ्यूचर में बी निकाल कर. इसलिए मैंने घोषित कर दिया कि पहला ए निकालना वैलिड है. So now guys, this is valid. So how do you know if it is valid? Simple thing. Analyze what will happen if you remove the a from index I if the leftover string is non-palindromic. If let's say the leftover string is non-palindromic, then obviously this is your answer. You can stop now. This is your answer. Stop. Stop the algorithm. It can happen ना that. चलो ये केस में तो ऐसा नहीं हुआ, बट कोई कोई केसेस में ऐसा हो सकता है बेटा. बताता हूं. Let's say this b was coming odd number of times. Okay. So now you try to remove the smallest character from the string. What will happen to the remaining string? Remaining string is triple A, triple B. Can this be solved in future? No need to solve it in future. It has already been solved. This is also coming odd time. This is also coming odd time. It means two characters coming odd time. It is already non-palindromic if you remove A. So this A, single A is your answer. If you remove this single A, your job is done. That's why whenever you remove the smallest character, if you remove the smallest character A from index I, if the leftover string is non-palindromic, non-palindromic means the leftover string already have two character having odd frequency or more than two character having odd frequency, then your task is done, your answer is done. Stop. But guys, what if this is not happening? What if this is not happening? What if it is like this? You again try to remove the smallest A from the leftmost side. Why I'm trying the smallest A from the leftmost side? Why I'm not trying the other A's? First, you should try the A on the leftmost side so that the remaining string has maximum options to do something in the future. अगर कॉमन सेंस की बात है ना, अगर कोई ए को निकालना है तो सबसे लेफ्ट वाले ए को निकालो ना. आगे वाले ए को निकालोगे तो बची हुई स्ट्रिंग का पार्ट थोड़ा कम हो सकता है ना भाई साहब. फिर क्या पता ये सॉल्व हो ना पाए फ्यूचर में. तो use the greedy mind and try with the leftmost occurrence of A. If you read my statements again and again, you will understand why we are only trying leftmost A for now. Okay. So in this case, if you remove the leftmost A, what will happen? You put it in my lexicographic subset. Remaining string is triple A, 4 times B. This is coming odd times and this is coming even time. Can this be solved in future? Yes, this can be solved in future by removing one occurrence of B. So basically, if there is one even occurrence in the leftover string, if there is one even occurrence, then you can go ahead and try to find the next character of your lexicographic minimum subset. Why? Because the leftover string has one character having even frequency. So if you make that even odd, then there will be total two odd. Got it? This one and this one. Okay guys, love you people, love you. So yes, you can remove this A in this case. So you can see here I have written, what if the leftover string has only one character with odd frequency? This is what which happened here, right? Leftover string has one character with odd frequency. in that case, if this is I, this range will be what from I plus 1 till n minus 1. So the range from I plus 1 to n minus 1 should have at least one character which has a even frequency. Because if there is a character with even frequency, you can always turn it to odd. If you turn it to odd, this odd plus this odd will become total 2 odd. Okay. So in this case, from the range I plus 1 to n minus 1, there should be at least, no one will explain you with this much love and care and support. Join Kumar K sir 850 hour DSA plus OA plus CP program and become the strongest as you can. There should be at least one character with even frequency. So in future, if you remove one from the character, it becomes odd. Okay, guys? And total guys having odd frequency will become 2. But guys, if this does not happen, then you cannot select this character in your subset. Sometimes it can happen that, let's say, this is a string and there is something here. Okay, you try to remove the first character A and you put in your subset. Now the remaining string, the remaining string has this character, let's say, coming for one character coming for odd number of times, and then there is nothing else. Then there is nothing else. For example, this string. Here you try to remove A. You put here A. What is the remaining string? B, B, B. Only one character coming odd number of times. Can you ever convert this string in the future to have two character having odd frequency? Can it ever happen? No, guys. You have totally failed. If the remaining string has only one character coming odd number of times, now you can never convert it to two characters having odd frequency. So there should be at least one more character having even frequency, so you can change it to odd and there will be two character having odd frequency. So in this case you cannot select A. In this case you cannot select A. In this case selecting A is invalid move. Invalid क्यों है बेटा? क्योंकि अगर आप ए को सिलेक्ट करोगे ना, तो ये जो बचा हुआ है ना बी 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 बी, ये फ्यूचर में कभी सॉल्व नहीं हो सकता है, क्योंकि बचा हुआ है जो भी ये होगा, इसके अंदर दो कैरेक्टर की और फ्रीक्वेंसी होनी चाहिए थी, बट इसमें तो एक ही कैरेक्टर की और फ्रीक्वेंसी है. सो इफ दिस इज नॉट वैलिड यू विल इग्नोर ए इज नॉट वैलिड. तो अब क्या करूंगा, अब मैं बी ट्राई करूंगा. सो लेट्स रिमूव बी. इफ यू रिमूव बी व्हाट विल हैपन? द रिमेनिंग स्ट्रिंग विल बी ए डबल बी. हियर ए इज कमिंग ऑड टाइम, बी इज कमिंग even time. A is coming odd time, B is coming even time. It means yes, selecting B is a good move. Why? क्योंकि अगर तुम ये वाले B को निकालोगे तो A ऑड बार आ रहा है, B इवन बार आ रहा है. ये एक ऑड हो गया. क्या फ्यूचर में सॉल्व हो पाएगा? अरे हाँ भाई साहब, इवन है ना, ये एक इवन है ना, तो इसको ऑड कर सकते फ्यूचर में एक B और निकाल के. So the single selection of B is a correct choice. So you first tried this A, this failed. So you try the next character B, this succeeded. So in my lexicographic minimum subset, this B is there. Now I will try to remove this guy. So this guy I have already removed. Can I remove the second B? Can I put second B in my lexicographic minimum subset? If I remove the second B, the remaining will be what? A and B. This also coming odd time. This also coming odd time. Stop. Both are already coming odd number of times. Oh. It means BB is your final answer. So guys, that's what it is done in the whole algorithm. What you are doing is that whenever you try to remove the smallest character, just check if the future string will be valid. Can the future string be solved? If yes, you can say that removing this current character is a good move. Lexicographic greedy algorithm. Doing the current move is good for the current case and the future case also. How will you check if it is good for the future case? If the remaining string already has two or more than two odd frequency, then job done, you can stop. If the remaining string has, let's say, one odd frequency and rest all are even, then also no problem. You can, in the future, you can convert that even frequency to odd. If the remaining free, it can also happen that the remaining string has all the guys only coming for even number of times, then also it's okay. If there are at least two guys coming for even number of times na, you can convert both of them to odd in the future and the job is done. So basically मैं ये कह रहा हूँ कि अगर ये a है, you try to remove this and you put it in your subset. Here this guy is coming even number of times, this guy is coming even number of times, and this guy is coming even number of times, then also no problem. Then also you can say that removing this a is a valid move and it should be removed. Why? Because in the future you can select any two even and you can make them odd na. So in the future you will be able to have a remaining string which will have two characters having odd frequency. Lovely people, love you, love you, love you. Now this thing is also done. So guys, now I assume that if I give you any string, let's say b, z, b, g, b, b, d, okay, in this string first you find the smallest character. Smallest character is what? B. So first I will try to remove the leftmost occurrence of b. I will try to remove this b. Is removing this b valid? Let's check it out. If I remove this b and put in the subset, the remaining one will be z, b, d, b, b, d. uh, Here z is coming, z is coming one time, b is coming three times, d is coming two times. So two guys are already coming odd number of times. No need to check for future this time, this is already valid. Because this is valid, b is the answer. Over. So hopefully you got the understanding that the algorithm is that कभी भी आपको कोई string दूंगा ना मैं, तो सबसे पहले आप सबसे छोटा कैरेक्टर ढूंढो, उसकी लेफ्ट मोस्ट अकरेंस ढूंढो. अब देखो क्या मैं इसको निकाल सकता हूँ. अगर इसको निकाल कर बाकी की स्ट्रिंग नॉन पेलिंड्रोमिक बन जाती है तो यही तुम्हारा आंसर है. बट अगर इसको निकाल के बाकी की स्ट्रिंग नॉन पेलिंड्रोमिक कभी बन ही नहीं सकती, ना अभी ना फ्यूचर में, तो इसको निकालना वैलिड नहीं है. बट अगर इसको निकाल कर जो बची हुई स्ट्रिंग है वो फ्यूचर में नॉन पेलिंड्रोमिक बन सकती है, तो इसको निकाल दो. समझे बात को? देर आर ओनली थ्री ऑप्शंस. देर आर ओनली थ्री ऑप्शंस. If at index I there is a here, if you remove it, now there are only three options. What is the three options? The first option is that the remaining part becomes non-palindromic. In this case, this is only your answer. Okay. Another option is that the remaining string becomes future oriented. In future, it can be solved. In that case, also you include a in your answer. And the third case is that the remaining string can never be solved. ऐसा भी तो हो सकता है ना कि रिमेनिंग स्ट्रिंग में एक ही कैरेक्टर ऑड नंबर बार आ रहा है. अब इसको फ्यूचर में तुम दो ऑड कैसे कर पाओगे? इफ ओनली वन कैरेक्टर इज कमिंग ऑड नंबर ऑफ टाइम्स इन द रिमेनिंग स्ट्रिंग, no matter what you do, you will never have two guys coming odd number of times. Okay. So in this case, now in this third case, you have to say that this is invalid move. Invalid move. Don't remove a. If it is the third case, invalid move. Don't remove a. In these two cases, yes, you remove a. Yes, you remove a. But in the first case, you remove a and stop the. You have solved the question. But in the second case, you remove a. Now you try to find second character to be removed. Okay. So these cases have been written there also in detail. You guys can check it out in the document. Don't worry, everything is in the description. You can check it out. Okay. So guys, once you are able to decide whether to put A in your subset or not, then you can go and try for which next character to put in your lexicographical minimum subset. If you want the subset to be lexicographically minimum, now let us say A becomes invalid. If A becomes invalid, lovely people, what will you do? You will now try for B, because trying for second index of A is useless. You can try for second index of A also, does not matter. But if A becomes valid, then you should try for second index of A only to make it lexicographically even minimum. So you keep on doing this process and the problem gets solved. Basically, you want, if A was valid for first care of subset, then you can try second care of to be second most smallest index of A. Basically, you want to know which character can be the first character of your selected subset. If char at index I is winner to become the first character of your subset, now you go through all the other characters whose index is greater than I. and check which one of them is valid. If multiple are valid, choose the smallest one. Once you are deciding that char at index I is valid to be put in the subset or not, you check what's happening with characters in the range I plus 1 to n minus 1. Either you can do brute force, but you want to pass this 7 star question, so you'll do in O of 1 time using hash map. In hash map से एक झटके से पता चल जाएगा ना कितने लोग उस रेंज में ऑड या इवन आ रहे हैं, या पूरे रिमेनिंग स्ट्रिंग में कितना ऑड इवन है. ठीक है. Find the next smallest char after I, if found to be valid, can be done using sorted set plus binary search. Make 26 sorted sets. Each set stores indices of each character separately as needed. In n into 26 into log n, you can solve this problem. Such a nice, brilliant problem. So let me show it to you how to solve it. Okay. Now, guys, I will run this algorithm in front of you. First, what you will do, I will make two sorted sets. In C++, Java, Python, you can make. I will store all the indices of A in some other list or set or list, and B on all other set and list. So first I will initialize my position as -1. So guys, now travel this list from A. Okay. My initial position is -1. Travel the list from A, B till Z and find a character whose index is greater than -1. Okay. So guys, I have this list A, I have this list B. I have to travel them and I have to find the character whose index is greater than -1. So if I travel A, I can see 0. There is a at index 0 whose index is greater than -1. So I will try to make this first smallest A in my subset. So guys, is this a valid move or not? Is this a valid move or not? Let's try. Check. If I put A, what will be the future remaining string? Triple A 4 times B. Can it be solved in the future? Yes, because one is already odd, one is even. So this even can be made odd in the future by removing one occurrence of B. So yes, it can be solved in the future. That's why this is a, yes, this is a valid move. So I can say 1A has already been selected. 1A has already been selected. You can remove that A without any fear. And you are sure that that A is contributing to the lexicographically minimum subset. Because you have removed the smallest character from the leftmost. Okay. So our subset now has A and this has been removed. Now guys, can I remove this? Now. I will update my position as 0. Now my position is 0, guys. Again, I travel the A list and the B list and find any character whose position is greater than 0. क्योंकि ये तो हो गया ना, अब आगे का ही चेक कर सकते, पीछे का चेक नहीं कर सकते, बिकॉज सबसेट मेंटेन्स द ऑर्डर फ्रॉम लेफ्ट टू राइट व्हेन यू आर सिलेक्टिंग अ सबसेट टू रिमूव. So guys, I travel the A list. Is there any character here having index greater than 0? Yeah, 1. So now I will try to remove this guy. Guys, can this guy be removed? If I remove this guy, the leftover string will be this. Can this be solved in future? This is coming even time, this is coming even time. Yes, this you can make odd in future by removing one more character from here, and this can also become odd. Yes. So removing this A is also a valid move. Yeah. So we will remove this A also. And remove this A and put it in your valid subset. This A also has been removed. Can I remove this A? Now my P value has become 1. This says that I have solved the things till index 1. Now in this range, I want to find the minimum character to remove. That's why I'm traveling the list of A and the list of B, and I'm trying to travel it, and now I'm trying to find the characters which are at index greater than 1. So easily मिल सकता है ना. I have a list of A and I have a list of B. First, I will travel the list A because A is a smaller character. Is there any guy here having index greater than 1? Yes. A at index 2. So now guys, can I remove this? Is removing this a valid move? I know no one will be explaining you this question in such a brilliant manner. I love you for doing and understanding this. Now, Can I remove this A? If I remove this A, the few leftover string will be A 4 times B. Ram Ram. So can this be solved in future? This is coming odd number of time. This is coming even number of time. This even can become odd, and then there will be two odd. Yes. So you can remove this A also. So remove this A also. My P will be updated as 2 means I have selected a subset till index 2. Now I can only select indices which are greater than 2. So 3 A's are there in my subset, guys. 3 A's are there in my subset, okay? And my P has been updated to 2. Is there any character available whose index is greater than 2? Yes, there are many. Which is smallest of them? A. Again, travel the A list and the B list, and as soon as you travel the smallest character list and you find that there is an index greater than 2 here, which is A of 3, you will try to remove this. Can I remove this? Can I remove this? If I remove this, what will happen? Is this valid? The leftover string will be B, 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 B. All coming even number of time. Guys, this is invalid. You can never do any operations on this future. You in future you cannot do anything to make it two characters having odd frequency. If all are B, you can do nothing to make it two characters having odd frequency. So it is not a valid move. This A cannot be removed. Cannot be removed. Cannot be removed. Cannot be removed. Now I will update my P position as 3. I have solved my question till P equal to 3. ओके, ये इसको मैं रिमूव नहीं कर सकता. इसको निकालूंगा तो ये फ्यूचर की स्ट्रिंग कभी सॉल्व नहीं हो पाएगी. रिमेनिंग स्ट्रिंग. So now guys, in this list, A is 0, 1, 2, 3 and B is 4, 5, 6, 7. Now, try to find the smallest character whose index is greater than 3. B. Let's try to remove B. Can you remove B? If I remove B, what will happen? The remaining string will be A triple B. Can it be solved in future or can it be solved now? Yes, it can be solved now only because A is coming odd number of times, B is also coming odd number of times. The remaining string is already non-palindromic. So if I remove this B and I add it to my subset, triple A B is my final answer. Stop. Guys, you have to stop as soon as you find out that the remaining string has two characters having odd frequency. So triple A B is the answer. Hopefully you understood the whole algorithm. Now whatever I am doing here, ना, you can optimize the time complexity. मैं क्या कर रहा हूँ? मैं हर बार 26 कैरेक्टर्स को ट्रेवल कर रहा हूँ. ये तो आपको पता चल ही गया होगा. At each index I, ना, at each index I मैं क्या करूँगा? At each index I, what I have to do? I have the list of A till Z, right? I have the sorted list of them. How to make the sorted set of this? You can search on GFG lead code or chat GPT. मैं ये सारे लिस्ट को ट्रेवल करके ढूंढूंगा क्या इसमें कोई कैरेक्टर है जिसका इंडेक्स आई से ज्यादा हो. I will just travel A list, B list, Z list. 26 lists I will travel. So 26 operations will go in traveling the 26 lists to find out is there any character in A whose index is greater than I. If there are multiple, I will choose the smallest index which is greater than I. If it is not there, then I will check for character B till Z. Why am I going from A to Z? Because A is the smallest character and smallest character should go in the lexicographic minimum subset. If A not possible, then try with B. But guys, traveling this A list takes time, na? So you can use binary search. This is the A list. Let's say A has these numbers. This means that A is coming at index 0, 5, 8, 10, 11. Let's say your I position, P position is 10. How will you find the first occurrence in this list which is greater than 10? You can use a binary search. In O of log n time, you will get that 11 is the answer. So you will know that at 11th position there is a. So you have to travel 26 guys, A, B, C, 26 sets. but in each set you can do in log n. So 26 log n for each index I. So for each index it takes 26 into log n time, and there are n indices, so n into 26 into log n. Okay, now let's solve one more case, and then it will be fully clear to my lovely students. So let's say it was something like this. Okay, yeah, it will be a good exercise, hopefully. So first of all, you will travel the A list and will try to remove this guy, right? Try to remove this guy. Can you remove this guy? If you remove this guy, what will happen? I'll try to put this A, right? So if you remove this guy, what will happen? B at triple A. Can this be solved in future? Yes, sir. It can be solved. It's child's task. It's even. It's odd. This can be made. This can be made. Let's say. Let's assume this can be made. Okay. This is even. This is odd. Okay. Okay. You are saying that, sir, this triple B can be made odd in the future. No, it cannot be made odd. Why? If you are selecting this index, na, in the future, you can do changes. If you are putting this guy I, if you are putting this guy I in your particular subset, in your particular subset, putting this guy I in your particular subset, it means that in the future you can only select the characters which are coming at index after this particular I, because you are selecting a subset, na. So if I do the changes in these triple A characters, na, it can never affect the B. So this even can never become odd. अगर तुमने ये चूज कर लिया फिर आगे से, और बेसिकली मेरे कहने का मतलब क्या है कि अगर ये तुमने ये को चूज कर लिया ना, तो बची हुई स्ट्रिंग ये होगी. बट बची हुई स्ट्रिंग में तुम सिर्फ जो कैरेक्टर्स 5 से 7 में आ रहे हैं ना, उन्हीं को इधर अफेक्ट कर सकते हो. ये भी कभी चेंज ही नहीं होगा, क्योंकि तुम बोल रहे हो कि तुमने 4 तक सब सॉल्व कर लिया बाय सिलेक्टिंग द ए एट इंडेक्स 4. So selecting this A is not working out for us, unfortunately. This A is not working out for us. Okay. So our position we were trying to find, at -1. This is not working out for us. Whenever this does not work out for you, you will again try the next character B. Okay. Because if the first character is not working out, it's common sense that the others will also not work out, guys. Okay. Hopefully that is basics. Things are clear to you. So now you will try for B. Can you remove a single B? If I remove a single B, what will happen? These are the remaining character. This guy is coming for odd number of times. This guy is coming for even. And I can manipulate both of them. This time I can manipulate this. I can manipulate this in future. Why? Why can I manipulate this in future, guys, lovely people? You can manipulate this in the future because, my lovely students, these triple A are coming on the right hand side. If I'm trying to remove the B at the 0th position, I can manipulate all the guys from 1 to 7 in the future. So I can make these A's coming even time as odd times in the future. So yes, you can select the B. Yes, you can select the B. Yes, you can select the B. So the B indices are, let's say the A indices, B indices, you tried the smallest guy in A and it did not work out. So you are now trying the B guy. Okay. For the B, the first guy did work out. Okay. Now, guys, if you are successfully removed this, now which character you will try? Again, you will start from A only. Again, you start from A only. Be truthful. Because A is the smallest character. Is there any A character which is having greater than index 0? Yes, this one. Can you remove this? Let's see if I put A here.
So what will be the remaining string? Triple B, triple A. And guys, this is already non-palindromic. This having odd times, this having odd times. Solved. B A is the answer. So guys, basically, hopefully you understood the algorithm. The algorithm is what? You have the list of all the guys from A to Z. Initial position you indicated as -1. Okay. Now what you will try now? You'll try to see if there is a character A which is hopeful. Yes, there is a character A hopeful. Okay. If you try it and it becomes invalid, then what will you do? Now don't try any character A. Now try the next one. B. The smallest character of B. If this also becomes invalid, try C. Keep on trying like this. Let's say something becomes valid. Something becomes valid. Let's say G becomes valid. After that, again, I will start from A and I will try to search a guy. Let's say the G became valid at index I. I will again try search for the second character. I will again start searching from A. Is there any character of A at index greater than I? Because after G, if A comes again, this will be lexicographically minimum, right? Hopefully, guys, this brilliant brainstorming is making your logical thinking and intuitional skills for greedy string, lexicographic, and palindromic nature strong as it could get. So, hopefully, love this session. Take care. Good night. Love you all. Ram Ram.